So we can go.
Should I start with, or you have something to mention?
I will just try to kind of connect the first two, just a couple of sentences. Okay, students, as you have gone through the two lectures we have gone through, the first one was introduction of air pollution, where mostly sir discussed about the composition of air and their relation with weather. And the second one was the kind of reasons and also the episodes, events, that is the history of air pollution. An example we have seen like London fog, smoke of Los Angeles, even a Delhi case has also has been discussed where all the government buses from gasoline and being transferred to compressed natural gas. And there is a change. We have seen that there is a change in air pollution, air composition, and their related things like the smoke is same. However, the particulate matter is less, whereas the amount of SO2 is more. Today's talk will be more focused on uh, air pollution control, and first lectures will be on air pollution control technology. So, this part with the history and the introduction part, that was very fundamental and extremely important. So, based on that one, now we will see how the control thing right now happening and other related things. All right. So, you, George sir.
Okay, thank you, Adhikari sir. Let me begin by saying, uh, when we go for this, or look for the air pollution control, what comes to our mind is, immediately we think of an industry, some combustion process, then a pipeline or a duct, then some device. Then the outlet goes to some joint, some chimney. From the top of the chimney, something is going. So our understanding of control is that particular box between chimney and the outlet of furnace. That's what is our understanding of control. But when it comes to air pollution, we do not usually directly jump to control. Few things that needs to be understood is, what are the criteria to choose a control equipment? Now, if we go one step prior to that, should we control or not? If we want to control, what should be the extent to which emission should be controlled? What are the actual right terms? It's actually emission reduction. We cannot control it fully, and we reduce the emission. Now, emission of what? Particulate matter, sulfur dioxide, nitrogen oxide. Now, we try to reduce it to the extent that it is economical. If we start spending too much of money on only control and say our efficiency of the system is to the extent that we do not let any pollutant go out, the way we talk of zero liquid waste discharge. In air pollution, we cannot do it because that violates second law of thermodynamics. Something we have to throw to the sink. So what is permissible that we can throw in the sink? There are a few criteria. First is legal requirement. Legal requirement means Central Pollution Control Board or Ministry of Environment and Forest, they have set up certain regulations. A few regulations, let me mention. From a thermal power plant, the current regulation is for a power plant capacity of 500 megawatt and above. The next is 660 megawatt. The emission of particulate matter should be less than 30 milligram per normal meter cube of flue gas. So from the stack or the chimney, the flue gas which is coming out, in that flue gas, the concentration of particulate matter should be less than 30 milligram in 1 meter cube volume of that flue gas. That is the current regulation, proposed regulation. Now that is one criteria for particulate matter. If you go some 5 or 6 years prior to this, the criteria was 50 milligram per normal meter cube. And 20 years ago, it was 150 milligram per normal meter cube of emission. So what has happened? Gradually, we are tightening the regulation, reducing the emission. What we will have to do? We have to increase the efficiency of the control system. So I'll go in a series of presentations, series of several PowerPoint slides. The last one will be on thermal power plant. How the uh, control in a thermal power plant, coal-based thermal power plant takes place. Then you will realize what is required to achieve that level of emission. Now, one thing I said, the three major criteria on which we decide the, or rather, why we need a control is, one is regulatory requirement or legal requirement. So as I said, in the case of a power plant, it should be less than 30 milligram per normal. Another criteria is economics. Now you can set up a system wherein you will bring down the emission concentration to 10 milligram per normal meter cube of flue gas. But is it needed? It depends on money available with you, resources available. Is it really needed or not? So cost is one criteria. There can be two systems. Suppose you have a back filter that can also bring the concentration to 30 milligram, and the other is electrostatic precipitator. So which one will you choose? The one which is cheaper. So economy plays a role. Now third criteria is to establish goodwill with the neighborhood. Now I can cite a few examples. Industries which uses there are certain industries that make gelatin from the bones of the dead animal. Now, if that kind of material is processed in a plant, the neighborhood is always smelling very badly because the emissions from such plant, and now they are not from the chimney or stack, their raw material handling itself emits a very foul odor. What those industries will do? They will approach, they will not, the local people will approach the regulatory authorities and they will ask to stop this industry, though they are not falling into any category of regulatory violence. It means the industry will face the resistance of the people. So another very important criteria is maintaining a goodwill with the neighborhood countries, the neighborhood citizens. So these are the criteria which decides should we go for a control or not. Now, I'll also give a case study of Nagpur city. There's a power plant which emits, causes pollution. Now, that pollution goes unnoticed because wherever you have set up monitor, it's not talking of those pollution level. So we have found something. Now, how to point it out that who is polluting? It's a very important question in modeling exercise, and that is called source apportionment. Who is the polluter? Because the plant is some 14 kilometers away from the city. So what tool we can use to identify who is polluting? So I'll begin with that. Now if you want to show from which direction wind is coming and bringing the pollutant, then you also need to know whether the wind is blowing in this direction. And if it is so, you need to know how to analyze that wind data. So I'll begin my today's talk with the analysis of wind data only using Windrose diagram. I think since the students are of undergraduate level, they may not have heard Windrose diagram. So I'll give explanation on that. So let me begin from Windrose diagram. Is it visible, Dr. Anubandhu?
Yes, sir. It's visible and slideshow mode.
Okay, okay, good. Thank you. So, my first topic will be today windrose diagram. Now, here, please mind the word wind plus rose. So, rose has different petals. So, from where? From there, this word has come. Why this we need to study? Here you can see a residential area on the right side and industrial region on the left side. Pollutants are emitted. The wind is towards the this residential setup. Speed is say 6 km per hour, wind speed. So from this, a decision maker can have a primary guess that at a distance of 5 to 7 km in 1 hour, the pollutant can reach. Now the wind doesn't change suddenly except in cyclone. It changes very gradually. So at a distance of 6 km is in 1 hour, the pollutant will reach and will persist there for some time. So if the people of this residential area wants to know from where the pollutant is coming, they can set up a weather monitor, record the wind direction, wind speed, and then plot a windrose diagram which will tell them the wind is coming from here. That is one useful utility of windrose diagram. Another utility of windrose diagram or wind data is establishing the runway in an airport. Mostly must have seen runways in airports either parallel or across, X-shaped. Why? The wind data of that region is analyzed for say 10 or 20 years, usually collected by Meteorological Department, India Meteorological Department. Then they find, so, say in the morning hour, a predominant direction is towards north. So runway should be towards north-south. The reason, if the wind is suppose east-west and we set up runway north-south, the crosswind will destabilize the plane and it will skid from the runway. So whenever the plane lands, the care is taken that the predominant wind is either along with the plane or opposite to it. Both plane can handle, the aerodynamic can handle, but not the crosswind. If you can recall, a few months ago, there was an accident in Kozhikode, Kerala. One plane skidded. What was the reason? The reason was it was a very windy day and the wind, crosswind, disturbed the rudder of the plane, the tail fan of the plane, that part. And because of that, the plane could not be controlled, it skidded off the runway. So the crosswind matters and therefore windrose data is analyzed for designing the runway. Now here we are going to do. Now since when the analysis started? So one of the known or documented version is 1843. A French artist named Leon Lalande, he created this diagram. From here, this is how he analyzed the predominant wind direction of the meteorological data or wind. Then today, computer era, you can see this is how the windrose diagram is shown. Now, what are the components? In the center of this diagram, you can see there is 30.73%. This is actually called the calm percentage. Calm means for 30.73 percentage of hours or time of the total data, the wind remained calm. Calm means less than 1 km per hour or 1 meter per second, whatever the plotter or windrose developer has assumed. So the central figure is calm percentage. Now you are seeing all the spokes from different direction. Now there is the thinner part inside blue color, then little wider red color, then still wider. So what is the thickness? the meaning of this thickness, what is the length of this spoke. I'll come in the subsequent slide. Following this, another approach is Bloom-Rose diagram. This I'll not discuss. I'll stick to Windrose diagram. Now, what is a wind data from where we can draw Windrose diagram? So these are the data requirement. For plotting a Windrose diagram, we need this much of data. One is the year, for which this is a format, typical format. Year, month, day, time. So time can go each hour. So you can see up to 24, then 1, 2, 3, 4 like this. Then wind direction, then wind speed. Now here I have not mentioned the units. You can choose units as meter per second or kilometer per hour. What is wind direction? Here some confusion is there, that let me clear. Wind direction convention. Now left side what you are seeing is a meteorological convention. Here north direction matters and all angles are measured from north in the clockwise direction. So here alpha is the wind direction. Okay. Now sometimes occasionally some students get confused with the trigonometric convention. In trigonometric convention, x direction is our routine Cartesian coordinate system. From here we measure alpha angle in the upward direction. So this is the first quadrant. But in meteorology, the wind is like this. So this should be known. Now another interesting fact is when we talk of direction, there is an issue whether the direction is showing from or to. This should be very clear, clarified here itself. Now I am mentioning two persons. One is an oceanographer and another is a meteorologist. Now let us see what is their interest. A meteorologist is standing in an industrial area, and what is his interest? He wants to face or find fresh air. That's what is a meteorologist's interest. He wants fresh air, clean air. What is oceanographer's interest? In oceanography also, the wind determines the direction of surface current, ocean current. So what is oceanographer's interest? In which direction the ocean current or surface wave is going. Why? Because in that direction his boat will go. Whereas a meteorologist finds he should get air from direction where the wind is fresh. He doesn't mind after touching him, wind goes in any direction. So meteorologist's interest is from where the fresh air is coming. Whereas for an oceanographer, the interest is where his boat will go. So you can see the difference is oceanographer looks for the current towards, whereas meteorologists look for the current or wind direction from. So whenever at any place wind direction is written, say 30 degree, it means from north direction towards 30 degree east, the wind is coming. That's the meaning of meteorological wind direction. So this convention should be very clear. Now let me show how the Windrose diagram is prepared. So here it is. The wind data for say 1 month or 1 year that is collected and then analyzed or broken or filled into this box. So you can see this row and column plot, this table. On vertical direction, left side you can see direction 0, 22.5, 45 up to 337.5. So this is something 16 direction wind sectors. So all wind direction which is from less than 22.5 degree, they are all falling into the top row. Now on the top header of this row table you can see it is 1.54, 3.09, 5.14. These are all the wind speed bins or groups. So if wind speed is number of hours, when wind speed is less than 1.54 kilometer per hour, we'll count those numbers and put in here. So it is say 7. So for 7 number of hours or 7 times of the total wind data, wind speed was less than 1.5 kmph and the direction was from north, 0 you can see, around north, less than 22.1. So here that is why this 7. So this is how the entire table is filled. If you make the frequency table, all numbers at the end here will be 0. From here we plot this Windrose diagram. So I think now you have got a clue what is Windrose diagram, why it is plotted. Here you can see for different direction dilutions. In this case, the wind is all from south. Now it's gradually getting spread from south, predominant wind direction. You can see the last one, the wind is spread in all directions. Okay, it's a very turbulent situation. Now I'm putting off this and going to second talk. Any question on this?
No, sir. So far, I did not receive any question.
Okay, so now I'm uploading.
Can I ask a question, sir?
Yeah, please, sir.
Sir, you mentioned one of the point like relation with the neighbor, and you gave an example. So, if and you also mentioned that it may be possible that they are not actually violating any kind of regulation from their side. So, is that being like considered like it's just the smell? Because
Okay, I'll give an answer. I frequently get complaints from different industrial area agriculturists. Though Niri is not the place where you can file a complaint. The complaint should go to the respective regional officers of Pollution Control Board. But unknowingly, the complaints are sent to Niri since it is related to air pollution control, so it comes to me. So I analyze those situations. At times, what happens, the ministers, concerned ministers directly intervene and they ask for what is your opinion on this before going into the legal aspects. The ministers, they call us and say, you just help us understand the problem. Is the complaint genuine or not? So one of the complaint I can share with you. In an industrial area, they were processing this iron billets. Okay, it was a metal processing industry. They were getting partly processed iron ore, and then they were making these small bullet-shaped iron balls, which they supply to the next vendor for its use. In this process, lot of coal is used, coal in its powdered form. The material, the iron bullets, that is dropped from a height, then collected at the bottom. So when it is dropped, it is coated with black coal dust. Now that gets lifted up. Next to this industry is the cotton field. The cotton crop's value is because of its white color. Now, if the black coal dust goes and settles on the cotton crop, what will happen? The crop is of no use because there is no value in the market. Now, this industry fellow says that I am not violating any rule. He is right. The person who is an agricultural, he says, I am not having no income this year because the entire crop is black in color. Nobody buys this. Nobody gives money for this crop. Now, how to handle this? So here both are right in their own way. Here the legislature come to play. Either they say, okay, the industrialists, you purchase this agricultural land and this land will be reserved. So you will not be doing any contamination because you have exhausted the assimilative capacity of that region it's of no use, nothing can be grown there. This example of cotton white is important. Even the regulatory authorities, the regulations, that gives liberty to violate the rule, the number, twice in a year. Now, just before harvest of this cotton, when the balls are grown up and white, if you release a small amount of carbon and that's deposited, his whole year's effort is wasted. And therefore, the relationship with neighborhood is important. Now, suppose some builder has gone and bought a big plot of land for making six-story building and selling it. Suddenly, someone comes out with a proposal of making a slaughterhouse nearby or a hide treatment system plant or something. What will the value of that land, that property? Because it's all going to be smelly all the way time. So there will be the nobody will buy that land, that flat scheme. So here neighborhood matters. So I think now I have clarified your doubt of why the neighborhood matters as far as air pollution is concerned, because things are not visible. One can only sense it by smell or visibility. So can I go to the next?
Absolutely. Thank you, sir.
Yeah. Now here I am going to show you the case study of Nagpur city, how the pollution in Nagpur city, it's not a very prominent or known pollution. It is something what I observed, studied. Now see this vehicle, a two-wheeler, soon after rain season was over. It's a post-monsoon season, 2009. You can see this white or to say uh, this streak of white color, creamy color. Okay. Now, no, this is the time when dew sets up on the material which is relatively colder. Nobody will say that this is rainwater or dew. This is actually dust fallen from the sky. Now the color shows it is not the dust which is lifted from the ground, because that is more dark in brown in color. So this color shows somewhat similarity with fly ash. So because fly ash is white or pale yellow color, that depends on its composition. It goes more towards white color. So when I observed this, then I again observed this car windscreen. You can see these white dots, not dots. It's a big amount of fly ash. So I started analyzing why it is so. Then not only this, there are several other observations too. That the closed cupboards inside the house, if you open sometimes, you will find a fine layer of dust. From where it has come? These cupboards have very small vents or very small area from where air can enter. Now, if it creates suction for some reason, what it will do, it will suck air from outside. Outside means indoor air, which is actually the ambient air. When you open the door, air exchanges by ventilation. So that dust comes inside the cupboards. And if you are a keen observer of these things, you can catch it. Yes, there is some dust fraction. I took that part and analyzed it. Then the air conditioner filters. So after summer, when you clean or before summer, when you maintain your air conditioner, open the filter. Don't just go on washing it. Gradually you remove the dust collected on it, subject it to EDXRF analysis. You will find what are all the chemical constituents that will help you identify the possible source of that dust. Is it from the vehicle or from some industry in the region? Here is Nagpur city. There is one power plant area called Koradi, which is 10 kilometers From Koradi, another one 4 kilometers away called Khaparkheda. And above it is Kanhan River. Now, for this setup, I'm trying to understand. This is the GIS map of a 25-kilometer radius, the central Nagpur city region, Koradi, Khaparkheda. This is in the previous picture of Khaparkheda, 2 by 210, 2 by 210, twin stacks, 2 power plants, another power plant of 500 megawatt. One more has come up recently, and here is the Kanhan River. This is Koradi, 5 plants of 210 megawatt. Here, old units you can see. Then new plant 660 by 3. 3 plants altogether, they are emitted through one chimney of 275 meters. So from one point, 1980 megawatt capacity power plant's emission is released. How it affects the surrounding region. So first I analyze the wind data. That is why I showed you in the beginning what is Windrose diagram. So here is the Windrose diagram. This is for post-monsoon region season. The average meteorology is like this. Now you can see the wind is not from east. It is east northeast. So this is the sector from where predominant wind is coming. Okay. Now their wind category also you can see the predominantly this pink color 2.1 to 3.6 meter per second. This is the wind speed class. On the left side, this column chart, here the wind speed is explained. Here you can see calm. Calm is 38.5%. Here also the same number is given, the lower part of this index, 38.52%. Here also, this is calm wind as per this classification. Now, then 0.5 to 2.1 meter per second is 39% of the time wind is in this speed. So on the left side, this box shows the wind speed distribution. And this circular diagram, this Windrose diagram shows the wind direction distribution as well as speed. So now imagine that the power plant is at the center of this. It will push the pollutants in west, south, west direction. Okay. Now what I do? I have used a model, a computational model called CalPUF. CalPUF stands for California Puff model that uses meteorological data for each hour of 1 year. So meteorological data for 365 into 24. That many rows, that much of wind data is used. There are a large number of other data to use. I am just here mentioning wind data. And comes out with the concentration. Here I have written GLC of SPM. Let me explain each term. Ground level concentration of suspended particulate matter during post monsoon. Then it is daily average, means for each hour the value is calculated for each point in the city. Then for each point for that hour it is average for one full day. So 24 readings of one day is average and one number is generated. That is how for the entire grid area the data is generated and this contour is plotted. So this is daily average. This is seasonal average. So for one particular season, post monsoon, this is the area which is predominantly polluted. So this is the post monsoon area. Winter. This is the windrows of winter period. You can see the wind is concentrated from one direction, mostly northeast direction. Now we can say it is from northeast. You can see the pollutant direction and speed for part of Nagpur it has touched. Okay, so this is the area where it is expected that pollution level will be high during winter season. Now this is how you can say the wind data is plotted and shown. It's a typical seasonal average. You can see the wind direction is going and then turning. This is how wind data can be used. So this model is Kelpaf model, and this is winter data. Now plume movement I'll show after some time. Now let's come to summer season. In summer season, you can see the direction altogether reversed, almost by 180 degree. It is west, not 180, 90 degree. From west to north direction, northwest direction, predominant wind is coming. So what it will do, you can see here is the power plant. This is the area that is going to be polluted. During summer, this is daily average. You can see seasonal average, the wind is in this direction, and villages in this area is affected during summer season, and during winter season they are not affected. So this is what is the use of a dispersion model, Kelpaf, and we come to know how it is happening. Now let me show you some uh, another, the what is called the plume movement, how exactly the plume from the stack goes out. Let me upload it. Can you see this? Is it visible? Some.
Yes, sir.
Yeah. Okay, so I am starting this, playing this. You can see from Koradi there is one plume, from Khaparkheda there is another plume. Now for each hour there is one plume from each power plant, power station, and how they for each hour they are assembled for one season. This I have done for a very brief period of summer. As I mentioned that in summer period the wind is in this direction and it is affecting the villages. Now you see how it is, they are dancing. 1 hour period is brought to 1 second and this animation is created. Now you can see how the plume will move. So this is this red color, this is the region where the predominantly pollutant will be there. So I am able to tell you how it is done. This is the summer period. Now I'll show you for winter how it is going. I'm just stopping it. Now this is it visible?
Yes, sir.
Yeah, now this is you see winter period. Okay, so how the winter wind is driving. This is going mostly towards this city, over the city. Okay, so during winter season, what it is doing, it is bringing pollutants towards the city. During summer season, it is pushing towards this village area, Kamti region it is called actually, cantonment area. So this is how we study the pollution. Now I'm closing this. Okay. Now I'll break for a while. Let me take a glass of water and then I'll come to the next topic. That is what happens inside a power plant. I've shown you what is wind data, wind arrows diagram, how emission from a city, from a power plant affects a city. Now, what is inside a power plant? So I'll take you to power plant. If you have any question, please tell me, ask me.
Anand, sir, I am having a small question.
Yeah, please, sir.
Shall I?
Yes, sir. Please
One,
ask
please.
your question.
Yes, sir.
Yeah.
Sir, in home, in ceiling fan, they used to have long, huge amount of dust, sir.
Yes.
Even though it is rotating regularly, it's holding a lot of dust.
Correct. A good observation. I also noticed it. I'm
And
going to get.
Sir, not
Yeah.
uniformly, sir, only in the edges of the blade and some directions only. That
Yeah.
also.
Yeah. Okay, let me try to search the reasons.
Yes, sir.
Let me try. One of the likely reason is if the wind is dry, there is a possibility that when the air is dry, not wind, air is dry, and an object is moving, it gets charged. Because the very basic question hidden behind your question is why it is sticking to that edge? Why not on the other part of the blade?
Not uniform,
Oh,
sir.
yeah, not uniform. One likely reason is it get that while moving, the edges get charged, then it attracts particles. Because deposition cannot be uniform since beginning. The deposition will be non-uniform, selective to the edges in the beginning. Subsequently, because of the deposition, it creates what is called an insulation. Then its movement may cause charging, static charge. That static charge maybe, that's the reason I feel so, may attract more dust that it encounters and allow its deposition by electrostatic force.
Yes, sir.
Maybe, I'm not very sure, but one reason I can find, that's all. Yeah, any other question? Okay, so should I go to next? Okay,
Yes.
I'm sharing. Now, is it clear, visible?
Yes, sir.
Okay, now this we are shifting towards a power plant. So before I get into the power plant, let me mention the sources of pollution. Broad classification is natural source and man-made source, also called anthropogenic sources. Natural sources, volcano or forest fire. And now if it comes to anthropogenic sources, mines, stone crusher, vehicular pollution, industry. Now inside an industry, what are all the possibilities? Raw material handling, as I mentioned in one of the cases, the metal industry, they are handling raw material, dumping something from a high elevation, it is causing problem. Conveyor belt, when it moves, it vibrates, the raw material lying over it or intermediates, that also shakes and causes air pollution. Furnace, where fossil fuel combustion takes place. Fossil fuel may be coal, LDO, HSD, or bagasse is actually from the cane juice. Once we remove the cane juice, what is left is the bagasse. So all these things go as a fuel, then causes combustion and subsequent emission. So now we'll go to power plant. When we study power plant, uh, we need to know a few things. And merely directly going inside the power plant ESP may not be that useful. Let's go first. How a power plant is set up. So here you can see there is a river water body. It means a water body is a must for a power plant to function because the raw material for a thermal coal-based thermal power plant is coal, water, air. These are the basic things which is required. Coal, water and air. Why air? It's abundantly available because for fire it uses air, and coal is for fuel. And why water? Because after the generation of electricity, a large amount of heat needs to be thrown out. How to throw it out? The steam, hot steam after the turbine, that we cannot throw it away because it is actually high quality water. Now that water we need to re-inject into the this our boiler system, furnace boiler system. We need to re-inject that steam. Now steam cannot be re-injected as it is because the boiler is under very high pressure. To re-inject the steam, we need to liquefy it from steam to liquid. Now in that process, we need to throw a lot of heat. How to throw that heat? It requires water body. Power plant per se do not use water. It uses water for cooling. So it is one of the major sources. Now let me show you. This is useful for those who are in the industrial engineering, mechanical engineering, or civil engineering, chemical engineering, how a power plant functions. This will give you some idea. It's not a complete comprehensive diagram. From environment point of view, usually we look from the stack. So on the leftmost part, you can see a chimney, flue gas that's going out. Now from where flue gas is coming? So here is one unit called ESP. This is electrostatic precipitator. So the outlet of this ESP is connected to this chimney. Now what is getting entered into ESP is the outlet of this boiler. So this is actually called boiler furnace assembly. I have made it just symbolic. This need not be exactly like this. It's only symbolic. This is the furnace in which we feed coal, air. Coal burns. Here is our boiler assembly. Boiler gets the high quality water. It's again reheated because we need to superheat the steam. Then it moves out. It goes to turbine, releases its energy. It is converted, and then all electromagnetic proper actions takes place. Now, why water is needed? Here I am explaining. From the turbine, after electricity generation, the steam which is of lower quality now because it has lost its pressure energy here, that is taken back to this boiler. Now how we can take it back? We need to liquefy it because steam cannot be pressurized. Our pumps will not pressurize it. We need to bring its temperature. How to bring it? Here is the condenser in which you can see from river we are taking cold water, circulating it outside in a jacket, and then, so what happens here? Heat is exchanged, this cold water gets into it and comes out as hot water, which is then discharged into this water body. Now the restrictions proposed by the regulatory authority is this hot water should not damage the aquatic ecosystem. If we feed directly hot water inside this river, what will happen? This river will be dead. Dead in the sense it will contain water, no aquatic life. All fishes and related species will die of high temperature. So there are certain limitations. Up to 40 meters, the temperature change should not be more than 5 degrees Celsius. That's what is the criteria here. Now this steam which is brought back, here it gets cooled down, some makeup water is added, then it is again brought here. So this is a power plant where we don't use any cooling tower. This is called once through system. Okay. Let's go to the second. Here it is with a cooling tower. So what is happening here? The same structure on the left side. Here what we do, instead of drawing water from a river, the one batch of water is cold water is used here, and then it is spread from the thrown out from the cooling tower top. It again air circulation takes place. There is an air circuit. It cools down this hot water, and then again this is used. So this is a power plant with cooling tower. Now, what is emitted from here is flue gas, which contains CO2, sulfur dioxide, carbon monoxide, suspended particulate matter, and mercury. Our focus is today this part, ESP, electrostatic precipitator, how it functions. Now, here are certain bookish definitions which I will not cover. All students, they can refer any textbook, they will get it, and they need to study, remember this particular term, Stokes diameter. The diameter of a sphere having the same terminal velocity and density as the particle under question. So this Stokes diameter and terminal velocity, there's a derivation, you can pick it up from any textbook, nothing big in this. Now let me come to the control part. So gas enters there can be several type of systems, gravity settler, cyclone, back filter, scrubber, electrostatic. We are talking of ESP, electrostatic precipitator. So it is known by its dimensions, height, width, length, how it matters, or why, what actually happens inside. The particle-laden flue gas enters into this chamber. Here, the velocity suddenly falls down. Why velocity falls down? Because this chamber's dimensions are much bigger than this duct. Now, if the velocity comes down, you will study in both water treatment, wastewater treatment, the settling chamber. So when particle goes in the forward direction, it also moves down because of the gravity. Now before it leaves this outlet part, if the particle touches the bottom of the tank, it can be removed or settled. So how to bring that particle away from the mainstream? Several forces are employed. One of the forces is electrostatic precipitation, which causes the particles to deviate from the main gas stream. Let me show how it is achieved. This is an example of a cylindrical ESP. This is not actually power plant ESP, but this is to explain to you how actually an ESP works. Here you can see this is a cross-section, cut view of a plant. You can see the gas enters from this lower part. It goes like this, moves up, and clean gas moves out. Particle gets collected here, which is then dropped down and brought out. Now, what is actually happening here? When the gas moves in the vertical direction, it contains particles. Now, here you can see there is one electric wire. Here is a ball. Now, why this ball and why this wire? This wire is hanging this ball or a weight that keeps this wire straight. Now, see here it is written insulator. Why insulator? Because this wire does not touch any part of this structure. It is totally insulated. Now, this wire is connected to a transformer rectifier set, TR set. It's a high voltage cable, from where the high voltage is generated, and remember it's a rectifier set. So the current is a direct current, not alternating current. The direct current causes electrons to move in this direction from here, but you will surprised to see that there is no earthing. It is not, this wire is not earthed, it is not connected to any body. So what happens? This contains electrons which jumps out of this wire. When this electron jumps out of this wire, they are attached with these particles. So the particles, the dust particles become charged, and this outer body, this is earthed. You can see here. So there is a potential gradient between this wire and the surrounding surface or the casing. So particles will have a tendency to move towards this body because it wants to discharge the electrons which it has gained here. Now, once the particles reach here, it will settle down and it can be removed. This is the basic principle of electrostatic precipitation. Here what is more very important thing is this cable which is coming down, it is not earth, it is given a direct current. Now how the shape of that direct current is, I'll show you through a transformer rectifier, TR set. Here, when we see inside a ESP, how it looks is, this is the main body, it's a plan view. These plates, this brown color, these are all the plates called collecting plates, where particles can collect. These circles are actually the cables, or this is called discharge electrons. From here the current is, the electrons are jumping out, and each cable is connected to a TR set. See, these are the cables. This releases electrons, it gets attached with the particles, and then the charged particle move towards the plate. Now these are all the electric field and potential distribution. You may not be interested, or you will find it in Harry J. White's textbook. This you need to be careful. What is the TR set and what it does? Usually when someone says direct current, so immediate imagination goes that there is one horizontal straight line parallel to x-axis, and that is what is DC. But it need not necessarily be. DC means the current which doesn't change its direction. So the curve, the voltage or current curve over time, it will not touch the x-axis. Here all these three currents are direct currents. Only thing is the voltage level varies. So what is required in an ESP is, so you can see the lowest figure, there is sudden jerk in voltage. It rises, then comes down, then rises, then comes down. So what happens when suddenly the voltage is increased? There is a rush of electrons, and then suddenly the voltage is brought down. And all this happens in fraction of seconds. So this rise and fall causes a large amount of electrons to leave out the cable, the electron wire from where we are trying to emit electrons. So that gets released. If we keep a single horizontal straight line, it will not help in releasing the electron. That is why this kind of current is required. Now, the thing that should come into your mind should be rather, who designs the electrostatic precipitator? Is it an environmental engineer, a mechanical engineer, a civil engineer, or an electrical engineer? If you can recall, in my first talk, I said it's a highly interdisciplinary subject. It's not related to one branch, and that's why it is not taught in any undergraduate courses fully. In each course, only the introduction is given. In India, the electrostatic precipitator is manufactured by Bharat Heavy Electricals Limited, BHEL. I think their Trichy plant is having ESP. Then Voltas and Flat, ABB, Asia Brown and Bowery. They are the companies which manufactures ESP. Current status, I don't know. I'm talking about long ago when I was working on this subject. So it requires very good electrical engineering. It requires very good electronic engineering, because generating this kind of current, DC current, requires very good knowledge of electronics. So the main force behind ESP is electronics, electrical. Then the structure which is erected, it requires mechanical engineers. The foundation by civil engineers. Now you can imagine how many type of engineers are required in a power plant study. I'm leaving it, nothing big. Now you can see here, this is a discharge wire from where particles are coming, and this is the plate called collecting plate. The particles get attached. Now this is a very thick layer of particles, the dust layer. If this continues to a large extent, what happens? Again, here the voltage gradient set up in the negative direction, and suddenly everything will explode and come out in the mainstream. That is why these plates are continuously, just hold on, I have a call. Hello. Yeah. Good. हाँ, वो टूर पे क्या नहीं अभी नहीं जी अरे आई क्या तो टूर पर ही जब से आई हाँ हाँ वो आएगी 10 दिन बाद अच्छा ओके मैडम मैं एक वीसी में हूँ मैं बाद में बात करूँ ओके hello sorry for the inconvenience I had a call okay now what happens here is this thick layer a negative voltage may set up potential gradient and this dust may come out in the mainstream and that is why frequently this plate is hammered it's also automatic hammering sequentially one by one so that this particle falls and then collected. What happens inside these ducts suddenly if the duct changes you can see this is the shape of the duct flue gas is coming here on the sides these are all the vortex zones dead zones where the dust particle deposition takes place. You can see this is the inside of an ESP distributor plate. From here onwards the ESP starts. So from duct the gas is coming hitting this. So this gets choked up sometimes. So this requires cleaning. This cleaning takes place once in a year. When you design the duct, if the duct is having a sharp bend, at the bend dust deposition takes place because there is flow separation. This you can see the transition zone, the main passage is blocked by the dust, fly ash. This I am leaving. This you can see, it's a scale is inserted to show 42 inches of dust deposition. This is at the inlet, not ESP is next to it. This is the velocity distribution along the height. Vertically the height, horizontally it is different levels along ESP. So you can see in the first section this profile 20 to 15 here what happens the flow is in the reverse direction. So please do not assume that inside the ESP at every section the flue gas is moving in one direction. It changes its direction. Here it's reversal. At the edges you can see top and bottom. Because of the presence of this body, the metallic body, the boundary layer, the flow reversal takes place. You can see this plate, then this discharge electrode, they are all coated with dust. So after some time we need to clean it, otherwise this will get coated, it will not discharge any electron and our efforts are useless. Then I'm leaving all these things and going to something more useful. This is for the students who are interested in the academics. What equation or mathematics is required? So this is modified Deuce-Anderson equation. Eta equals 1 minus e power minus WA by Q. Here the most important parameter is drift velocity. Drift velocity means the velocity by which particles move from current electrode to collection plate. That is the value, drift velocity. More this number, good is the collection efficiency. A is the total collection area, means how many square meters of metallic plate you are hanging on which the particles get attached. So this is the equation. In some examination you will get this kind of questions. Let me help you by saying some questions looks very big but answer is in just 2 lines. You write down this equation eta 99%, another issue 99.9%. What is the collection plate area? You solve this equation, this divided by It's 99 divided by 99.9 or efficiency, yeah. And then when you solve this, you will easily find the value of A. Rest all things you assume equal, all cancels, you will find the A is proportional to, directly if it is 99 to 99.9%, 10 to the power 2, it goes in that direction. Order of magnitude it changes because it is exponential. So this is a clue, you can solve this problem. Now, this I think should be the last slide, which you should know, it's very important. Well, let's compare US European coal power plant versus Indian power plant. Indian power plant says ash content should be less than 34%. Now this 38% I wrote when I wrote this paper 20 years ago. So US or European coal is having an ash content of 10%, and our ash is 34 or 38%. Their calorific value is very high, 6000 kilocalorie per kg, and our calorific value is low. So we need to burn more amount of coal. Now coal consumption per kilowatt hour of electricity. So they use small amount of coal. We need to go for large amount of coal. Sulfur content, theirs is 2%, ours is very low. Now we should feel blessed that our sulfur content in coal is low. But there is an issue. If the sulfur content is low, the fly ash is having highly resistive nature. And resistive nature of fly ash requires more electric charge to be applied on so that this particle gets charged and then attracts towards the collection plate. Ash generated, they are generating an ash amount of 41.7 gram per kilowatt hour. We are generating 271. So what is the outcome? The electrostatic precipitator size, if we are having one, they are having 1 unit for the same power generation, we have to employ an ESP of 6.5 times larger than this, their ESP. This is the basic difference. Now what has happened, our new rules have brought the very strict control. So this 6.5 have gone double now. So this is all what I want to say today. Rest all, I don't think it is for the day. All of you must be tired. So I'm putting off to this. Yeah. So please tell me if you have questions.
Thank you, sir. Couple of questions, yes.
Yeah,
it's often, actually, a question came from a student. Let's take that first. I think which is a very good question. She wants to ask that the air purifier available in the market, what is their mechanism, how they purify the air, and how to decide whether these are necessary for us or not, or let's say how much it is needed actually.
Okay. I believe the student who has asked this question, their concern is about indoor air purifier. It's to clean a room. Okay. Now, let's have an oblique thinking. In Nagpur, we use lot of, during summer season, we have large size desert coolers because the summer is very, very extreme here. The temperature goes to 46, 47, 48 like that. And if daytime temperature is very high, night time it doesn't get cooled down and the temperature is very high, difficult to sleep. So instead of air conditioner, ACs, here the preferred choice is this cooler, desert cooler. And why we call it desert cooler? It doesn't employ simple fan. It uses exhaust fan, large size exhaust fan. Then what we call khas, or that wood wool on all the sides, sprinkle water from the top. So that water cooler is more helpful in Nagpur. Now what that cooler does, by the end of summer, or not to summer, after 15 days or 1 month of operation, if we see the body of that wood wool, which allows air to pass through and go inside the room, lot of dust. So what this cooler is doing, it's actually cleaning the air. It is throwing clean air inside. That's one way to think. Now, those who are economically rich, they tend to have tendency of buying some gadgets which they will set up inside the room, which will purify. Now, what such mechanism can do? If you use this desert cooler, it will certainly clean. I have given an example, and you can also see, check, believe it. Now, suppose you want to buy indoor air purifier supplied by either some German or Japanese or Chinese company that pleases you because it gives you a status of being of richer class. Okay, let us analyze those air purifier. They claim that they have a HEPA filter. Means ultimately they are having a filter. Filter means here when I see a desert cooler, that is also having a filter. Here also in the indoor air purifier, they have a filter. What it does is it's take out sucks the dirty air from the room, cleans it, collects the dirt in a filter and throws out the clean air inside the room. Now what is happening here is inside the room, the unit, this air purifier, this can be of the size of say 1 meter by 1 meter by 1 meter or a cylinder, let us assume a cylinder. So it is drawing air from one end and discharging clean air at the other end. Now, if you keep on operating this instrument for say 4 hours, 2 hours something, don't you believe that there will be a circuit established between inlet and an outlet? Just think over it. If there is a way to set up some signature, marker or color to air. So when dirty air enters, from where it is sucking the dirty air? Inside the room itself? If the machine continues to operate, it will throw clean air outside. Between inlet and outlet, automatically there will be a circuit established. It's a natural because there is a pressure gradient setup. Unless you keep on stirring the air inside the room. How to stir it? Put on the fan. This is one issue I feel. Okay, now your air purifier is not a moving object. It is hanging on a wall or kept somewhere. If it is kept somewhere or hanging on a wall, it will clean the air of that region continuously. In between, if you open the door somewhere, then again there will be some exchange of air. I don't know how effective it is. I have not yet worked on this. I organized one workshop here in my office, invited all stalwarts of indoor air purifier. Everyone gave their opinion. My opinion are a bit different, but I can't help it. Now, this is one point that these filters, these air purifiers are using filters. They claim that this filter contains some chemicals which removes volatile organic compounds. It is possible that inside the room, if VOCs are captured, pass through some carbon bed, it will absorb and then pass out the good clean air. It's admissible, acceptable. Third point, first point was there is a likely possibility of circuit between inlet and outlet. Second good point is it can clean VOCs, but does our houses have VOCs so much? If we stop burning agarbatti, dhoop, and there's less of VOC. Think, is it only for particulate matter? Then filter is sufficient. Then these purifiers claim that they have electrostatic precipitator inside, a small ESP. Now, let me ask, the ESP which I showed you for a thermal power plant, the electrons charge oxygen and it generates ozone. inside a room, do you want ozone? No, we don't want ozone inside a room. It is not good for health, it is not good for lungs. So, how ozone will be generated? If the polarity is inverse to what I suggested in power plant. Now, what happens? I myself did one experiment. One gentleman gave me his air purifier, which he used for 6 months. He said, if you want to test it, you can test it. I took it, brought it here in my office. First thing, when I tried to open the nut, it gave an electric shock. The reason they had ESP inside, but all ESP should be earthed. If it is not earthed, the static electricity will store in the body somewhere, all metallic parts, which they didn't take care. When I opened it, I realized, yes, it is storing electricity, static electricity. So if anybody claims that their indoor air purifier is having electrostatic precipitator, then put a question, how the static electricity is discharged? Is it earthed? Because mostly these IAQs are hanged on the wall or kept in the corner. There is no provision of earthing in that. Now, another point is, when I opened that box, suddenly I started lot of having itching on my face. What happened? I opened and removed that filter. Filter contained dust. Not only dust, lot of biological entities, because that became breeding ground for microbes. Unknowingly, it was my mistake, or rather, by this I learned that when you open an indoor air purifier, be careful. It is a place where a lot of microorganism can survive. I opened it and immediately started having very severe itching. So this is my opinion about indoor air purifier, which I shared. Anything else, please?
Second question, sir. How refrigerator release CFCs?
I think actually one of my topic was here, ozone layer depletion, but I didn't take it because it was, I think, last or in the first talk itself I wanted to talk, but because of time limitation, I didn't say. The candidate who asked to him my suggestion, what happens? If you complain to this refrigerator fellow supplier that my AC or refrigerator is not working, they come check and then say, "Sahab, gas leak ho gaya hai, top up karna padega." This is the way they fool us, because the top up karna, this word has come from mobile charging. थोड़ा 100 रुपए का टॉप अप करा दिए. Wrong. Very basically, AC or refrigerator, all these devices have a very high pressure pump. Now this CFC are circulated inside at a very high pressure. If there is even a pinhole, with that high pressure, everything will come out. So there is no question of top up. It's idiotic. If there is a pinhole, everything will come out and under that high pressure, and then there will be no cooling. So ACs and refrigerator never releases CFC. The student who asked, tell them it never releases CFC. It releases CFC either when the tube gets broken, the copper tube through which the CFC passes. If it's broken, then only the gas releases, not otherwise. Second thing is, when we put it in the junkyard, dispose this refrigerator or AC. So the CFC which it contains, the pipeline if you break, and mostly what is done, it contains copper which is having good scrap value. So they break it, take the copper, but in that process CFC gets released. Otherwise, if there is even a pinhole, the CFC will get released. There is no issue of top-up business. That's fooling, some other problem. They take some money, 5,000 रुपए का मैंने charge कर दिया. Learn this subject. So next.
Sir, so in India right now, is there any statistics or chart like which is contributing most to raise the CO2 level in India, sir? Like vehicle or industry or indoor pollution? Like, is there any kind of like
Statistics.
any
Okay.
kind of study? Yes.
I don't, I'm not able to recollect because I have not read this for quite some time, but this data is available because we are a part of international greenhouse gas convention related issues. So, and uh, he also got Nobel Prize for this particular stream. What is that? Greenhouse gas reduction strategies. So it's well known. Now let me say how to estimate or how to know which what is contributing more towards CO2. Let's compare the carbon India is consuming compared to carbon which China is using, America is using. We get our carbon consumption through coal because we know what is the production from coal mines. If there is production, the same is consumed. Consumed means it is burned, CO2 is released. So that is the way we can understand how much carbon we are burning. Coal we are burning. What is our crude oil import? Compare, let's find per unit of crude oil, what is the CO2 generation? These two sources are sufficient. Now here the question is, crude oil is mostly used in vehicle part. Coal is used in steel, cement and power plant. Now compare who is using more, who is emitting more. So you will find ultimately it is coal, not the other. But distribution of vehicle is more in the country, whereas coal power plants are centered. Either it is load centered or pit head centered. So they are at concentrated points. They are released at a higher elevation. Vehicles release at very low level near the ground. So these are the things which is from where we can find relative comparison. Who is polluting or emitting more. So
Is it okay for another couple of questions, sir?
please,
One
sir.
question.
Yeah, please.
Uh, One student asked, what happens if you use hydrogen gas in air conditioner?
Okay.
Or
Let me respond to it. Uh, the student has asked question. He wants to replace CFC with hydrogen. Okay. He should think first why CFC is used. What is that something which property of CFC? Now, is that property available with H2 or not? Hydrogen or not? Let's compare the two. CFC is having a property of compressibility. Remember the force required to liquefy it from gas to liquid because the latent heat or the Gupta Ushma, that is something used in this refrigeration process, whether it is AC or fridge. So this compression, liquefaction to gaseous conversion, that is what is making it useful. Now, if you use hydrogen, does hydrogen have those properties? Can hydrogen be compressed to liquid with such easy effort? Means, have you ever seen hydrogen transported in liquid form? No. Hydrogen is transported in gaseous form because it cannot be compressed at our available resources, that is the compressors that we use in a fridge or AC. In that, hydrogen cannot be compressed to liquid. That is why we cannot use hydrogen in place of CFC. So I think students should have learned when he's putting a question, he has the answer. What is the property of CFC which has made its position in refrigeration? Sir.
sir, just to the student, so I think in thermodynamics unit, if you can remember, there is a slide based on how refrigeration works. Compression chamber, release chamber. Yeah, you can just have a look at that one. Sir, just one, this is the last question. This is from me, from my side. Uh, whenever Deepavali comes, like the first question asked about being a citizen, um, do not use these firecrackers. They do a lot of air pollution, and that's for a couple of days. Many cities, their campaigns and everything. But I will just ask you that couple of days firecrackers by us, is it that big amount compared to, even if we compare a daily emission by industrial vehicle in India? Is it like we can see it? That's the thing. Whenever firecrackers, the smokes comes out, creates a noise, we can see it. Is it because it's like we can feel it more? That is why there are so many restrictions and concerns, or really it creates or generates gases at that extent?
Okay, let's break this question different parts. First thing, one point that you mentioned, comparing this firecracker emission with industry and vehicle. So let's put all these three: vehicle, industry, and firecracker. Industry emits at higher elevation, say 100 or 200-meter high point, and it is emitted throughout the day. So the pollutant which is emitted during daytime, because of the high ventilation, high mixing height, that pollutant have a chance to move out and spread into the atmosphere. Vehicular emission at lower level, that is also emitted throughout the day, not at night. So evening vehicular movement causes higher pollution concentration. Daytime vehicular movement causes relatively lesser pollution concentration. Now comes to firecracker. It is always 9:30, 10:30, 11. Or I'll start when my neighbor's firecracker is finished to show him that I am left with something more. So firecracker starts at a time when inversion sets up in the atmosphere. Inversion means, I don't think I have explained this in my first talk. Inversion is when we move upward from ground surface, the temperature, natural condition is the temperature should come down. But after 6 o'clock, after sunset, the earth radiates its heat. So the lower level has a higher temperature. So that is, we say, inverse. As we move up from the ground surface, the temperature increases for some distance. That distance is called inversion height. Any pollutant released within that distance will remain there. It will not go out into the atmosphere. So what happens if you use firecracker, which you do it at the surface level, except some rockets, okay? So when we burn it at ground level, it releases pollutants. Of course, it has got moisture. That is why H2O, so it shows white color, fumes, smoke. But it remains there for the whole night at the lower atmosphere. So some people who is having breathing trouble, they will get affected. This is one way of comparison. Now, where second very important point, all fossil fuels, when burned, it releases CO2, SO2, NO, which gets converted to NO2, and then subsequently ozone during daytime. But these firecrackers emit metals. These metals are toxic. It uses boron to bring color. If you burn firecracker, if it doesn't give color, there's no point to bring. And from where this color comes? When the electron jumps from one shell to other at high temperature, it releases its energy. That wavelength color is the color of that firecracker. So it really uses metals. Now these metals are harmful to us because if we breathe more of that metal, they are heavy metals, and this heavy metal causes damage to our organs. So these are the way it is comparing. Now one more point we can think while analyzing this cracker. When Lord Rama came from Ayodhya, towards Ayodhya after conquering Sri Lanka, were there firecrackers at that time? Yes. If we see Mahabharat serial, you can see that very big arrow and rockets. So if we go by the theory, yes, firecrackers were there. But if we go for the last 100 years, firecracker is a recent business. 100 years ago, we were not having this many firecrackers. Hardly we had this gunpowder, that's all. So can we, for a while, assume that let's go back and gradually come forward. Let's go 100 years ago and then come for, let's again start celebrating Diwali. What were there at time? At that time, we didn't have Chinese LED bulbs. We had only diya, because I remember my childhood, we had only diya. So from diya we started, and those days actually it was purer days. Ghee jala lete the. So from there we started. Now we have electric bulbs, then LED. Now this firecracker is a recent addition. So one can think of considering its reduction without, means do not relate these things to emotions or religious sentiments. But these things are not to be, we can discuss it, but not to be taught by the academicians. This is something those religious leaders, politicians who are more responsible towards social upliftment, they can talk on these subjects. We are not, we can discuss it, we can talk, we can bring these things to them, they will decide what to do with, how to deal with this subject, because a big section of firecracker manufacturer, their labors, they are associated. Now, our society has generated that. So what will happen today when you say, no, ban firecracker, then one faction will immediately bend towards the firecracker manufacturer, starts showing their plight. When the issue was raised, it was raised by the people who are affected. Now, balance is health or economy. That needs to be understood. I hope I have partially answered you.
Absolutely, sir. So it's more like this quality of the pollution. I should not say use the quality, but different type of pollution than regular gasoline or coal burning.
Yes, yes.
Okay, sir. With that, I would like to thank you. And now I would like to move to Somakanta sir for concludatory remarks and to deliver the vote of thanks. Sir, your voice is not audible. Somakanta sir.
It's fine now. Respected George sir, respected faculty friends, and dear students, it's last 3 lectures of George sir, how interesting it has been. So we are really lucky to have a guest lecturer or guest speaker with us like him. So he has explained many fundamental things that we never thought of. So I hope all of our students have enjoyed all these 3 lectures. So with this, I, on the behalf of Chemistry Department, VITFP University, sincerely thank to the invited expert, Dr. K.C. George sir. Thank you very much for giving your time, for sharing your knowledge with us, with our students. We are really happy. We are really lucky to have you with us in this EVS lecture series. Thank you very much, sir. Thanks a lot.
Thank you, sir. Thank you.
Thank you, sir. Sir, if it is possible, can you give us some FTP on air pollution for our faculty members also in near future?
I'm not getting. Once again, sir, voice was broken.